Hi, this is Mrs. Myers, and this is our review video for Geometry 21, Chapter 4. And this is the extra review that I gave you in class. So we will just be explaining these problems and doing a couple of the proofs. Okay, so this first one, make sure you're marking your diagram, PO congruent to QO and RO congruent to SO. Remember that this triangle is an isosceles triangle, so therefore across from the two congruent sides are two congruent angles. And in the other triangle, it's also an isosceles triangle, so across from those two sides are two congruent angles. But the four angles are not all congruent to each other, so let's put a double mark here and only a single mark up there. So this is 40 degrees, that makes angle 2 40 degrees. And since 40 plus 40 is 80, that leaves us 100 degrees of our triangle for the measure of angle 7. And by vertical angles theorem, this angle here would be 100, which means we have 80 left for 5 and 6, and they're both the same, so each one has to be 40. Oops, 5. And by linear pair, we see that this angle here has to be 80 because it's a linear pair with the 100. So if that's 80, and we're given that PSR is 105, this whole thing is 105. If this part of it is 40, that leaves us 65 left for this angle right here, 65 here. So that means in this triangle, so many triangles here, this triangle, we've got 65 in this angle, 80 here, so that leaves us 35 degrees for angle 3. And angle 4 is going to be the same situation on the other side. Okay, let's move on to number 2. We've got, again, an isosceles triangle here. These two sides are congruent, which makes these two angles congruent. And then this direction, we've got another isosceles triangle. So these two angles are congruent. Again, doesn't mean all four angles are congruent. Just within each triangle, there's some congruence. Okay, so if this angle's 20 degrees, that means angle 2 is 20 degrees. And between these two 20 degrees, we have 40 degrees, so that leaves 140 left for this angle here. And that's a linear pair with angle 3, so angle 3 would be 40 degrees. Then angle 4 has to be 40 degrees also because of the isosceles triangle theorem. These two angles are congruent. And since those are both 40, that makes 80, which leaves 100 degrees for this angle here. That's 120, which makes the measure of angle 5 60 degrees. All right, number 3. Got a lot of markings in this diagram to give us hints. Measure of angle 1 is 23 degrees. Measure of angle 2 is 23 degrees. Together that makes 46 degrees. This is an isosceles triangle. That's how we know those two angles are the same. 46 degrees, therefore 180 minus 46 gives us our leftover 134. So the measure of angle 3 is 134. Oops, let's do 2 first. Now, from here, we have to look for other clues. And this little arrow and this little arrow tells us that this line is parallel to that line. I don't see any z's here for alternate interior angles. I don't see any angles at all on the exterior. So I'm going to look for same side interior. And it turns out 3 and 4 are same side interior angles. Like this. Same side interior angles. So if angle 3 is 134, then angle 4 has to be 180 minus 134, which is 46 degrees. And since that's 46 degrees, we have another isosceles triangle down here. 5 and 6 are congruent. So we take 180 minus 46, which we already know is 134, and split that in half, and we're going to get 68 degrees for each. Measure of angle 5 equals 68 degrees. Nope, sorry, 67. 67 degrees for each. I knew that didn't sound right. And, and then angle 7 is just going to be what's left over to make 180 degrees here. 180 degrees. So if we have 23 there and 67 here, that makes 90. So angle 7 is going to be the 90 degrees left over. Okay, number 4. We're told that this angle is 35. We know that these two sides are congruent, therefore the angles across from them are congruent. So measure of angle 2 equals 35 degrees. Then we have angle 3 right here, which is a linear pair with this angle, angle BDA. We also know that angle 5 and angle 6 are going to be congruent. Sorry, 5 and 4 are going to be congruent because it's an isosceles triangle again. Therefore, there's a couple of ways we can do this. This is 35. Angle 3 is an exterior angle of this triangle. So by exterior angles theorem, remember the exterior angle is the sum of the two remote interior angles. So the measure of angle 3 has to be 70 degrees. It's also a linear pair with this one, so we could have gotten this as 110 and then done 70 that way. But since angle 3 is 70 degrees, that leaves 110 degrees between these two, 5 and 4. So 110 divided into two equal angles is going to be 55 degrees each. Number 5, 100 degrees here, that's our one clue. Well, that tells us that this one would have to be 80. It tells us also that since this is parallel to this, with this as our transversal, then this angle 100 degrees and angle 4 are alternate interior angles. So angle 4 is going to be 100 degrees as well. Now, if this is 80, then this has to be 80 because of the isosceles triangle theorem. These two sides are the same, therefore the angles across from them are congruent. So the measure of angle 3 is 80 degrees. We also see that this is an isosceles triangle. Let's go yellow again here. We've got this isosceles triangle. Sides are congruent, and the vertex angle is bisected. So that tells us that this line here, since it's the bisector of the vertex angle of the isosceles triangle, then it must also be the perpendicular bisector of the base. That was that theorem that we learned. So therefore, the measure of angle 2 is going to be 90 degrees. Perpendicular bisector makes that 90 degrees. Well, if this is 90 and this one's 80, then 90 and 80, we have only 10 degrees left for the measure of angle 1. Another way to get that would be to look at the whole yellow triangle as its own triangle with two angles of 80. That makes 160, so this whole angle has to be 20, and then it's split in half, so it's got to be 10 each. So these are 10 degrees each. All right. What am I missing here? Angle 4, we didn't write that yet. Measure of angle 4 is 100 degrees because of alternate interior angles theorem. Measure of angle 4. And then these two are congruent, so these two angles are congruent. So if this is 100 degrees, that leaves us 80 between these two angles, so 40 each. So measure of angle 5 is 40. Also, since it's the perpendicular bisector of the base, that makes x equal to 8 centimeters. All right, number 6, we have a lot of triangles here. This triangle, let's start with this one. This angle 2 is marked congruent to this corner angle here. It's also marked congruent to angle 3. It's got two congruent sides. Therefore, the angles across from those two sides are congruent. So it turns out that all three of these angles are congruent, which means all three of these sides must be congruent, and it's equilateral, which means the measure of angle 2 must be 60 degrees, because the three angles of an equilateral triangle are all equal to 60 degrees. Okay, so that makes angle 3 60 degrees. And if we look at this next triangle, I'm going to hold off on angle 4 for a minute. Look at this next triangle. This is 42 degrees. So 180 minus 42, and then cut into two congruent pieces, this whole thing, these each have to be 69 degrees. The whole thing is 69 degrees. Angle 3 was 60, which means this little piece in here is 9 degrees. Okay, so when we look back at this equilateral triangle, this whole angle was 60. This little piece of it is 9, we said, so the measure of angle 4 has to be 60 minus 9, which is 51 degrees. Okay, and then the measure of angle 5 is just a linear pair with 69 degrees. So that's going to be 111. And then the measure of angle 6, these two angles are congruent because they are across from these two congruent sides. So it's isosceles triangle. If this is 111, then we have 69 degrees left for these two angles. 69 cut in half is going to be 34.5. Okay, so 34.5 for angle 6. Oops, 0.5 for angle 6. Okay, let's look at the other side. The longest leg of triangle ABC. Okay, if we're talking about a longer leg, then we have to be talking about a right triangle. Longer leg, because in an isosceles triangle, which have legs, both the legs are the same length. So this has to be a right triangle, and AC measures 10, and BC measures 8, the other leg. So A, C, and BC. So this has to be C, and that has to be A, and this has to be B. Okay. And we have a second triangle called XYZ, and AC is congruent to XZ. So I'm going to make this one 10 also. And BC is congruent to XZ. They both have Z in common here, so Z must be at the right angle. So this is XZ congruent to AC, and YZ congruent to BC. So that's going to be 8. So can you conclude the two triangles to be congruent by the HL theorem? I'm going to say no, because we don't have hypotenuses. We only know legs. We don't know hypotenuse congruent to hypotenuse. We only know legs. So we could use SAS. side, angle, side, where the right angle is the angle that we're using. Okay, determine what other information you need to prove the triangles congruent. Then write the congruent statement and name the postulate theorem you would use. Okay, to use SSS, well, we know this by reflexive, so we would need AD congruent to CD. These are the ones we would need. I'm going to erase them because we have to keep using this. So the only thing that stays constant is that reflexive. To use SSS, we would need the other sides. To use SAS, so if we have these two sides that are marked, the angle for SAS would be this one. So it would be angle ABD congruent to angle CBD. Those two, in order to use SAS, would be what we would need. Number 9, to use SAS, so we know vertical angles are congruent, so we'll leave those constant. To use SAS, we have SA, we would need this side, YV congruent to XV. And to use ASA, angle, side, we would need this angle, angle U, congruent to angle W. Okay, and then the last one, to use AAS, we would need this angle, angle, side, so we would need angle Y, congruent to angle X. Okay, to solve for X and Y here, don't overcomplicate this. These two angles are congruent. 3x minus 11 equals 2x plus 11. So we're just going to solve for x by getting x's on one side. Oops. So we get x is 22. If x is 22, that means this is 44 right here. 2 times 22 is 44, plus 11 is 55 degrees. And here, 3 times 22 is 66, minus 11 is 55 degrees, which we want them to be the same, so that works out. Together, that makes 110, which means this angle here must be 70 degrees. So 2y equals 70, and y is 35. B, we have this triangle is, again, an isosceles triangle, so 3x plus 10 equals 5x minus 10. Subtract 3x on both sides, we get 2x equals 20, and so x equals 10. Plug in 10 here, we get 50 minus 10 is 40, 30 plus 10 is 40, so together those make 80, which means this angle has to be 100, which means on the other triangle here, we've got 4y, and this angle have to be congruent because it's isosceles. And we just said that angle has to be 80. So we just need to say 4y equals 80. And y is 20. Okay, for number 11, given that these two triangles are congruent in that order, then QS has to be equal to TV. So 2x squared minus 3x equals 2x plus 12. Get everything to one side. You're going to get 2x squared minus 5x minus 12 equals 0. We have to factor. You may want to use your box method here. 2x squared, negative 12, multiplies to be negative 24x squared, adds to be this middle term, negative 5x, so what multiplies to be negative 24 and adds to be negative 5, that's going to be negative 8x, and positive 3x. So negative 8x here, positive 3x there. Take out the GCF. Here we're going to take out a negative 4. Here we're going to take out an x. Down here we're going to take out a 2x. And here we're going to take out a 3. So our factored form is going to be x minus 4 and 2x plus 3. So when we solve for x, set them both equal to 0, and we get x equals negative 3/2. When we plug both of these in, they actually both work. So we want the values of QS and TV. QS is 2x squared minus 3x. If we plug in x is 4, we're going to get 2 times 16 minus 3 times 4. That's 32 minus 12, or 20. If we plug in, same thing, QS, 2 times negative 3 halves squared minus 3 times negative 3 halves, you could plug negative 1.5 in to your calculator if you'd rather do that. But if I square this, I'm going to get positive 9/4 times 2 is 18/4 plus positive 9/2, which is another 18/4. So that gives me 36/4 or 9. Now, when you plug in both of these, I'm not going to do it right now, but this is the easier one. Plug in 4 right here. You're going to 2 times 4 is 8, plus 12 is 20, which is what we wanted it to be. And then also if you plug in negative 3 halves, you're going to get negative 3 plus 12, which is 9, which is what we wanted it to be here. Just match these. So your two answers are 20 and 9. 20 and 9. Okay, name the included angle. We learned about included angles when we talked about SAS. A was the included angle. So if we are going to mark PN and NM, PN and NM, the angle that's included, sorry, we had an interruption there. So angle N would be the included angle. Okay, this is taking longer, sorry, than I thought it was going to. For this proof, we have angle 5 congruent to angle 6, and PX congruent to PY. And so we want to prove that PAB, this big triangle, is isosceles. So we're going to have to get PA somehow congruent to PB. So I'm looking at what they gave me here, and I'm thinking I'm going to be able to prove these two triangles, this one and this one, congruent, and then I can use CP/CTC to say PA is congruent to PB. Okay, so we have our givens, and from PX being congruent to PY, then I could say angle 1 is congruent to angle 2 by the isosceles triangle theorem. And from there I can say angle 3 and angle 1 are supplementary, and angle 4 and angle 2 are supplementary by the linear pair postulate. So then I'm able to say that angle 3 is congruent to angle 4 by the congruent supplements theorem. Therefore, we now have enough information to say triangle AXP is congruent to triangle BYP by ASA, because we have that side, this angle, and this angle, ASA. Then we can say AP is congruent to BP by corresponding parts of congruent triangles are congruent. And then you can say triangle PAB is isosceles by definition of isosceles. Okay, proof number 14 I actually have here on a separate sheet here. This came out to 11 steps. And that's about it. So just make sure that you are studying these proofs, practicing your isosceles triangle theorem. Make sure you know how to factor, and make sure you know how to solve systems of equations. But remember, you don't always have to solve a system when you see x's and y's, like the problems that we just did. Here, sometimes you don't want to overcomplicate things. Right here, there was x's and y's, but we could solve the x's separately and the y's separately. It's not always a system. Sometimes you can solve them without having to do two equations at once. Okay, good luck.